Yuji Yazawa from Toyota, also Andrey. Andrew, how do you pronounce your last name?
Yeah, that's the most difficult part here. Kudryavtsev.
Sorry.
Yeah.
Kudryavtsev.
We will practice. We will practice later, Larry. You will have lots of time. Yeah, Kudryavtsev is good enough.
Great. We also it's a pleasure to invite Andrey from Intel. He's project manager for the Intel DAOS team. After this meeting, send us feedback. Let us know how you like it, or if you have any comments, input. Also, let us know. We'll try to make it better moving forward. So, without further ado, let's get started. Let's have Yazawa-san kick off the meeting. He's going to discuss and let us know, explain some of the use cases and challenges they're facing at and opportunities at Toyota. Yazawa-san, go ahead. Maybe in the beginning you can introduce yourself.
Oh, okay. So let me share my presentation. All right. Hello everyone. I'm Yuji Yazawa from Toyota Motor Corporation, and my background is more than 8 years of the storage engineer on the Yahoo Japan, and I was managing a couple of 10,000 of physical server products and a couple of petabytes of storage product on Yahoo Japan. And after that, I moved to Fusion IO and Scality as a sales engineer. And finally, I joined to Toyota on 2017. And I'm responsible for researching and planning our next generation IT platform, which dedicated for the Toyota and Lexus connected vehicle, as well as autonomous vehicle. And we Toyota is trying to gathering how to say much more data from Toyota vehicle, and using those data to the many new functions, such as more safety function, or kind of dynamic maps, or virtual agents, something like that, as you can see. However, this is a preliminary assumption of the data capacity calculated on the AECC, which means Automotive Edge Computing Consortium. So if the vehicle improves the function and sending many data to the cloud or our data center, we need to expect exabytes of data in the worldwide. So I mean, we need to think about not only storage layer, but also network layer, especially mobile network, for the community cost reduction. So I mean, we have many issues and many challenges on our future environment. And then at this moment, we mainly using public cloud environment. For example, Microsoft Azure and AWS. But if we think about a huge amount of data on our environment, we need to think about not only we need to think about not only processing.
Shut up, bitch ass.
Can we proceed?
Yes.
No.
Yes. Hello.
Shut the fuck up, bro.
Who is this? Yeah, Yazawa-san, go ahead.
Okay. So if we think about processing huge amount of data on the public cloud environment, we need to think about.
Wait, is this the meeting for the SODA Foundation?
Yes. Who is this?
Bobby Rossi.
Okay. Do you have questions or we just got started?
Yeah, I was just making sure I was in the right meeting.
Okay. Yeah.
All right, thanks.
Thank you. Yeah, Yazawa-san, go ahead.
Okay. If we think about processing huge amount of data on only public cloud environment, we need to think about the cost must be expensive. So we need to think about not only public cloud environment, but also on-premise environment. And at this moment, we don't have any regulation and rule regarding to the data came from connected vehicle. So if the government established any rule for the connected vehicle related data, if we think about long-term data archiving, so at this moment we are thinking our data retention time must be around 15 years. 15 years meaning the average time of the Twitter vehicle manufacturing to.
Excuse me.
Sorry.
This is Hanstead. So I joined a little late, and I'm a big investor here, so this is very important to me. I'm just wondering where the tier 1 storage is going to be located exactly, global wise.
It depends on the each region. We have many rules, too many rules on there. So we don't have a globalized environment. We will prepare the environment for each region. So one environment for US, one environment for, let's say, EU, one environment for China, Japan.
All right, thank you. And then Larry, I have a question for you. So
Yes.
are you the CEO or what's your role?
I'm the chair of our outreach community.
Oh, that's chair of the outreach. All right.
Yeah. Which company you work for?
GGS.
GGS. Okay.
Yeah, we're a small startup.
Okay.
About 2 weeks ago, we started. We just invested quite a bit of money here. So.
Okay. Sounds exciting.
Yeah.
Okay.
Yeah, in fact.
Can you hold off questions until later once Yazawa-san finish this
sorry about
presentation.
that,
Okay, thank you very much. Yeah.
Thank you. At this moment, we are thinking the data retention time is 15 years. So we are considering offline storage for realize super long-term data archiving using tape or archival disk or something like that. And for cost reduction and better energy usage, we would like to store those tape and archival disk on the warehouse for offline archiving. And we also need to consider edge data center for the better latency, reduce latency. So I mean, we need to think about many kind of locations and many kind of storage, such as tier 1, tier 2, or something like that. So at this moment, we are thinking very compromise the architecture using many kind of storage products, and we need operation very long time. So for make the operation easier and reduce operational costs better, we need Toyota need SODA, especially data life cycle management and cold storage collaboration, as well as multi-cloud capability. So that's it. Any questions so far?
Does anyone have questions for Yazawa-san?
Yazawa-san, do you run any type of Kafka applications to process the data from vehicles?
Yes, we are at this moment we are using Kafka on data injection environment, injection layer.
Yeah, it makes sense.
Mm-hmm.
And when you categorize it to the tiers, how do you usually work? Do you set some specific like a performance metrics between the tier 1 and tier 2 storage, or it's a proximity to the data? So what comes first when you create a criteria for tiers?
Good question. Is based on at this moment based on performance, especially, and the definition of tier 1 is basically data within 3 months, and tier 2 is half years or 9 months is, and cold storage must be data more than 1 month, 1 year.
Yeah, that's for data retention. Thank you.
Right.
Any other questions for Yazawa-san? No? Okay. All right. Yazawa-san, thank you very much for the presentation and insight and the challenges and use cases.
Thank you. Thank you for listening.
Thank you. Let's move on to Andrey. Andrey from the Intel DAOS team. He's going to give us an overview of DAOS project and also some latest update on the project. Go ahead, Andrey.
Of course.
Thank
Happy to
you.
do that as well. This can be interesting for Yazawa-san. And in general, I just want to give an update to the team, what we are currently working on and what is the current scope of the storage program that we have at Intel. Of course, Larry and other SODA participants, they know that DAOS is currently one of the SODA Eco projects. We're really happy to be the part of the SODA Foundation, and I'm happy to present here today some results of our work, some recent results. So basically, to set the stage really briefly, 2 minutes, what DAOS is. DAOS is high performance distributed storage. Basically means that it's a distributed compute environment where you have storage systems connected with some network, and they run together the unified storage system, which can be a file system, that can be some application-specific stores, but they deliver the performance and capacity by growing in a quantity and scaling the size of the storage. It's very typical for cloud HPC. There are other types of the solutions that are already in the market, such as Lustra for HPC for many years, such as Ceph in the cloud for many years as well, and others. There are many examples of this. But basically, our target is performance. Really, what we are looking at, the differentiating ourselves to be a high performance solution. And usually when it comes to some really type of like a cloud environment or customer environment, we work in a tiered configurations. So exactly as Yazawa-san presented, so you may have a different installations of various file systems and storage solutions working together and basically orchestrating the data by the temperature. So high temperature data, hot data, simple, it goes to typically the high performance storage, in that case is DAOS. But we work jointly with other storage solutions for data movement. So when it comes to the some, let's say, data migration, so now we can take care of basically pass the data from one storage tier to another storage tier, or use some other technology to do this data migration. So it works both ways. The point here that it's in many cases it's a hybrid. So you typically go for very high capacity cold storage, which can be a hard disk based, and you integrate it together with a high speed storage, which is roughly 10% lower capacity than your cold storage. So that's really, 2 minutes why we're doing this. The interesting part of the DAOS design that from the end user perspective, it can go in various scenarios. It can be your file system of choice. So basically addressed to the POSIX interface like regular storage, like regular file system. Or it can be very specific to the way what application you're running and what framework you're running. So for instance, for AI applications, we can interface directly to the TensorFlow or PyTorch. And this will allow to program DAOS like it would be the application store. So it's no longer files, it's no longer directories. You just interface, the DAOS as extended store to the TensorFlow and store tensors directly on DAOS. And this is what TensorFlow allows with TensorFlow IO library that is exactly designed for that. the main advantage here that it simplifies the path for the data and it accelerates the data significantly. In similar ways, we are doing other types of integration, like you can program DAOS like it would be a memory for the Python applications. And for big data developers, it's no different than its memory. So you just store your, let's say, data structures. Instead of memory, you store it in DAOS. You call them with the DAOS calls, but it's not any different from your like typical like in-memory applications that you do with a Python. And there are other examples. So we also bring in support for some, I would say, industry standard interfaces such as tree, such as block interface. So that's all included in DAOS. We haven't originally planned to do that, but we see customer requests, and that's one of the program updates that we had recently. That basically our customers would like to see as many as possible ways to integrate it, and they don't want to be locked to one particular way how they communicate to DAOS. Underlying DAOS solution is basically a high-performance key value store. So we can build on top of a key value pretty much any type of like a data interface and data structure. We can simulate file systems, like here's an example of Hadoop, simulating Hadoop HDFS, Hadoop distributed file system. And in a similar way, we can do other interesting things on top of that. The underlying hardware technology is actually really interesting because we are tiering the data to the metadata and the actual data. And actual data is always stored onto the NVMe SSD. So we do not interface to hard drives by default at all. DAOS is completely user space application inside out on the server side. So we communicate to the hardware directly using user space libraries. And we just don't have any layers to go to the hard drives at all. For the metadata, we are using several ways. One of these is using Optane technology. Some of you might have heard about this. That is called Intel Optane persistent memory. Well, there are several announcements about this persistent memory that it's going to disappear roughly in 2025 because of future development of this technology has been stopped. And we basically run the metadata off the persistent memory or of the other types of the configurations. So we have basically dual development path, and one can run on the persistent memory, CXL.mem persistent devices. They are not available. They are not yet available in the market. So, but many vendors already introduced these products, such as Kioxia introduced flash drive over CXL.mem. Samsung introduced memory semantic SSD. SK Hynix introduced CXL MEM devices. So, and that would be growing for sure. But the overall ecosystem is not ready for that yet. So I do not expect these drives to be in production any months or later this year. It will take some time next year to catch up with that and see the actual mass-produced devices in the market. But we see the evidence that it's coming. So that is on the left side of this, DAOS design using metadata for persistent devices. And on the right side, what if we use the technology which is already today available, but it's not persistent memory? So we're running a development that uses a combination of a DRAM plus a journal on the NVMe SSD. It's called write-ahead log. So basically, that's a log that is constantly appended with metadata changes. So metadata stored in DRAM. But in order to secure it from the power interrupts or server crash, we synchronously update the write-ahead log that sits on the NVMe SSD, and we do that sequentially. So every change of a metadata just appends with another change in the log. And this is how we can get the performance relatively similar to persistent memory. So there are some advantages and disadvantages to go that path. The disadvantages, of course, the latency of these devices is much higher. But on the positive side, that we can increase concurrency because we now working with asynchronous block device where we can submit many IOs if they are not, conflicting each other. So that can be out of order IO execution that goes to the NVMe SSD, and we can get a decent performance. And all of these come sequentially with appends. So it's really for us, it's a nice way to manage this type of installations. So these two developments, they've been just recently announced about a week ago, and we are going to share more details on how the technology is working for the volatile device path soon. But in the meantime, we already demonstrated lots of, I would say, performance claims for DAOS and how it works overall and what is expected performance publicly. Many of these performance statements are part of like our HPC community engagement. And within HPC, there is IO500, which is the storage benchmarking rating of the different installations. And we are really proud to say that we have the installations, production installations of DAOS running on the real systems, of course. But we also have a customer who tried to run the same hardware for DAOS and for Lustre. And the performance difference is just vastly different between the two storage systems running exactly on the same hardware. So this is where it comes to the advantages of the software implementations, efficiency, user space operations. And we shared that data earlier this year at International Supercomputing in June, and really proud about this. DAOS is open source product, so everybody can contribute. We are excited to see when we see external contributions and see partners working with us and contributing and working on some advanced features for DAOS. We have many examples like this in the community. I highly encourage you just to watch daos.io, and from the main page you'll get access to the GitHub. You'll get access to our Jira system for issue tracking. You'll get access also to mailing lists and to DAOS Slack channel. So we're really open community, and this is what it makes really interesting to work with SODA Foundation because it's all open, and we can make storage much better if we will be working together. So this is it. If you have any questions, I'm happy to answer it.
Hey, Andrey, I think I heard that after Yazawa's presentation, you made a comment that you think this will benefit end users such as Toyota. What was your thought on that?
Yes, of course. I mean, because most of the time when you work with the streams of the data, let me tell you some examples, like streams of the unstructured data or streams of the sensor data. You need to guarantee some type of like a quality of service to the tier 1 storage. And this is really when it comes to the performance requirements, because it's not just what the bandwidth of this storage. Bandwidth comes separately. The quality of service requirements, they come primary because you need to push the data as soon as possible and make sure that this data arrives onto the storage within some time. So that's why I was wondering what type of criteria Yazawa-san sees at Toyota, and that's why I think DAOS can be very interesting in this regards, because we don't need to store files. We can store files if it comes as a file data, but that can be much more interesting if it comes as raw data, or if it comes some structured data that we can directly put into the DAOS key value implementation and place it as the data structures, not as a data files, because at some point you have to execute some operations on this data, do some filtering or do some processing before you move on, right? So and it would make it much easier if you have a structured data already sitting in storage that is specialized for that, and that can increase just the time of the processing. I can give you several examples of such type of installations. Again, I hope they can be really demonstrative. One of our customers, who is running the scientific physics experiments, so that is European CERN agency who runs a big Hadroid collider. You know that. They have a huge incoming stream of sensor data coming off the system, coming off the collider, and they need to place this data into the storage before their buffer overflows, because that's a constant stream of data. You can think about that as a similar like a car data, car telemetry. That's why I was asking, for instance, about Kafka. Well, in case of the CERN, it's just everything is running at such a high rate. So you have to guarantee that the data will be on the storage. And more importantly, as soon as experiment over or during the experiment, you want to start the processing of this data at the same time. So it might be just some data filtering, such as if it's like a really sensor data, you want to filter some noise out of that data. It's a good example. Or it can be already some physics on top of the data produced. So this is where you really need high performance storage, but because it's a structured data, you don't want to put that into files and then process files and then parse files. You want to make sure that the data is easily accessible. And that's what CERN did. They build on top of DAOS. They build their application set that stores the data in a key value format. And for them, it's more like a database. So they put the sensor record in this database, and then get this data, sensor data out of the database is much easier. And then you can implement, because it's all like a custom database. Within this database, you can implement some non-standard functions, such as filtering or functions that I already mentioned that you can process on top of the DAOS data. So it's just a different way of the thinking of a data pipeline. And of course, at some point you migrate the data outside of DAOS when it comes to storing these data and moving it to the cold storage. That all makes perfect sense. So you execute it on the data, and then you no longer need it, you move it outside. So that is a certain example. We have several cloud customers who are running DAOS in their infrastructure, and they use it for their also like a telemetry data. So if some order comes, let me not go into the details of these customers because I cannot disclose these. But if some order comes, again, it goes to the DAOS first. And DAOS for them, it's like a very high performance key value store, not like your typical file system. It can be file system, but all the advantages really come when you start saving that in your own format of your data. And then this order comes, it comes quick, it comes with guaranteed level of the quality of service. And so it's persistent in the system. So you may think about that like a huge database that you define, and it's a fully distributed, and it can synchronize to another DAOS installation. So for instance, if you have 2 cloud services, you can synchronize one cloud site to another cloud site, and data will be synchronously available on both.
I see. Yeah, very, very interesting. I think that's very important for a lot of end users in our community. They have a lot of huge amount of data needs to be processed real time. I see like autonomous driving, if which is needs that kind of a solution. Yeah.
I agree. And with changes that we implemented that allows building DAOS at, well, first of all, open source at no cost, and the very minimum requirements to the hardware. Of course, the network performance is part of the storage performance. You cannot design high performance storage without high performance network. And this is what you define first. What is my network configuration? And again, for high performance compute users, typically the fabric of choice is InfiniBand. So it's a de facto standard. For cloud customers, Ethernet typically is a fabric of choice. But we see many changes in the cloud infrastructure where while companies invest into the RDMA accelerated Ethernet, such as with Rocky. And this is where it really comes to the to the performance. So you run, let's say, 100 gigabit Ethernet with Rocky, and you run it with very low latency. That allows you to scale your storage performance and really put some innovative technologies onto this fabric. Because if it's like 10 gig Ethernet, you don't need any of this. You'll find other different ways how you can build it because all your performance advantages will be eaten by your low network performance. So fabric comes first, and then it comes to the storage.
Yeah, that makes sense. Yeah, in the future, I think it would be great to have more discussion about the integration with SODA, right? So we have
that would be great.
That'd be integrated solution and work for end user from application down all the way to the storage networking layer. Yeah. Any other questions from anyone? Okay. Thank you, Andrey. Thank you very much so much. Thank you, Yazawa-san, also providing the presentation earlier. So I think that's the first wrap for our first meeting. I think this kind of meeting is interesting because we have kind of requirement, also solution. Presentations from vendor, also from the end user. That's kind of very interesting, mutual beneficial opportunity for both sides. So let us know any of your comment if you have any comments for future meetings, and so we can make it better. If no other questions, that's it. Thank you again. Thank you everyone for attending.
It's a good start. Congratulations.
Yeah, thank you very much. Thank you, everyone. Bye-bye.
Thank you. Bye.
Thank you. Bye-bye.
Bye-bye.